Population and Communities, Chapter 5. So, what is a population? A population is a group of the same species that live in a specific geographic area and also can interbreed. If the two species live in the same geographic area and they look the same but they cannot interbreed, like certain species of finches, then they are not the same species. Sometimes we'll see certain animals will interbreed, but their offspring are sterile, and they create a hybrid species. The hybrid is not necessarily a new species because it cannot genetically reproduce its own offspring. So it's just made a hybrid. That's a one-time generation. It's not a multiple generation. Now, once that hybrid can now have babies of its own, then that would be considered a new species. They can be small or large in numbers. They can stay near the same numbers for a long period of time, or they can increase or decrease those numbers. The dying out or lack of resources, the dying out of a species is usually caused by a lack of resources or because of competition. Understanding how a population grows is important because populations of different species interact and affect one another, including the human species. Population growth. The size of the population depends on 4 factors: birth rate, death rate, immigration, and emigration. Immigration is the movement of individuals into the population, such as you immigrate to a new country. Emigration is the movement of individuals out of a population. So the people that would leave the old country to come to a new country would be emigrating from their old country and immigrating in from a new. The 2 major models are to show growth are the exponential growth curve and the logistic. Exponential growth is a J-shaped curve. This would be an example of the human population. This occurs when numbers increase by certain factors in each successive time period. It is usually seen as a J-shaped curve, and the population would continue to grow exponentially until it hits its climax. Most of the time, we don't know where that happens with an exponential growth. The human population has been in an exponential growth rate. A logistic, or also we use a logarithmic growth curve. We reach a carrying capacity. In a logistic one, we will see that it will reach and maintain its carrying capacity, or K. This carrying capacity is the largest population an environment can support during a given time. In a logarithmic curve, we'll see a lag phase of low population numbers, a logarithmic increase, a stationary phase, and then we'll go into a death and decline phase, hitting a lag phase again. If the lag phase is not hit and it would go to 0, that would cause an extinction of a population, or it would be a removal of the population within a specific geographic region. Factors that affect population size. Many factors cause population to grow and shrink, and such as water, food, predators, human activity, and many other factors. Abiotic factors are the non-living factors that would affect population size. Weather and climate would be an example of abiotic factors, such as there was a temperature swing of a very high temperature or a very low temperature. Biotic factors are those that are living factors within an ecosystem, such as the amount of food, disease that may enter a population, or the introduction of a new species. The introduction of an invasive species or a new species into the environment can lead to competition problems. Competition can then lead to removal of that species or the elimination. In the human population, today we have 6 billion people, and increasing from there. We no longer have 6 billion people in the world, we have much more. Reasons that we have an increase in the human population: better sanitation, hygiene, disease control, and agricultural technology. We're able to produce more food in a smaller space. We're able to keep more people in a smaller region. Historically, 200 years ago, there was only 10 million people. We started seeing the Industrial Revolution, which allowed the human population to start increasing exponentially, and we haven't gone back since. Science and technology are also reasons for rapid growth within a population. The agricultural technology allows for us to support the needs of the population by genetically modifying organisms, and medical advances and vaccines have lowered our death rate. Right now, we're currently in the corona pandemic. We are seeing still an exponential growth, but we are seeing a dip in our population, which is caused by an increased death rate.